Hello everyone. Now let's discuss about scanning electron microscope. Scanning electron microscope means here the main thing it will do is it will produce a magnified image of the surface of the sample. This is used to study the surface of the sample, surface structure of the sample. For this we will use scanning electron microscope. Here, uh, first thing is it will produce a magnified image of the sample. So principle, here a fine pencil of beam of electrons of high energy, it will hit the sample. When that electrons hit the sample, means it will scan the sample. When they hit the sample, then it will give off backscattered electrons, secondary electrons and characteristic X-rays. First, we need an electron gun. This electron gun will produce high energy beam of electrons. These electrons are attracted by anode. These electrons are attracted by anode because it is positive charge in nature. As it will attract, it will give a direction to it. As it will attract, it will give that direction to it. Direction of the electrons are given by anode because it will attract in this direction. Second, magnifying lens, we need a magnifying lens which is also known as condenser lens. Now this, it will focus and narrow down the beam of electrons. Means it will give a direction to the electrons. Any electrons are there here, will remove those electrons so that only electrons flows in that particular direction. Narrow direction. Next, we need a scanning coil. Magnetic coil or focusing coil or scanning coil. This scanning coil, it will make that beam to move across the sample like this scanning coil will help that beam of electrons to move left, right, up, bottom across the sample so that it will scan. That's why it is known as scanning coil. Next is objective lens. Objective lens, it will make that beam of electrons to focus on the sample. This will help the beam of electrons to focus on the sample spot. Then it is scanned. Now when the electron hit the sample, then these electrons will bounce away. So the electrons which are bounces away, these electrons are known as backscattered electrons. These electrons come from that beam of electrons only, that fine beam only. Second, if that electron collide with the atom inside the atom on the sample, then that atom is knocked out. That atom will come out from that sample. That atom is known as secondary electrons. Those are known as secondary electrons. Means those come from the sample. Third, when that fine beam of electrons collide with the atom inside the sample, then X-rays are produced, characteristic X-rays are produced. So in this way, backscattered electrons, next is secondary electrons, third is characteristic X-rays are produced. These signals are collected by the detector. Detector will collect these signals and it will transfer this information, these signals to the monitor so that image is produced. Image is produced on the screen. Next, here this process will repeat 30 times per minute to get a clear image. So 30 times it is repeated every minute to form a clear image. Next, applications of SEM, scanning electron microscope. Applications is first thing we all know that it is used to study the surface structure of the nanomaterial. So we can analyze the surface structure. It is used in topography, means study of the surface texture. Second, it is used to study the morphology of the surface of the material, nanomaterial. Morphology means we can study the size, shape, arrangement of atoms on the surface. We can study with the help of the SEM. Third, composition. We can identify what elements are present in the sample with the help of SEM. Next, composition. This is composition. Next is crystallography. We can identify how atoms are. We can study how atoms are arranged inside the crystal with the help of the SEM. Thank you.